Okay, good morning, everybody. A couple things. Your Chapter 5 quiz is due Wednesday at midnight, okay? You guys know that. Multiple choice. You can take it twice. Highest score counts. As well, we're getting to the point, we're going to kind of end Chapter 6 today. So that means Chapter 4, 5, and 6 we're going to be done with. So we're at a point where we want to have another exam. So either, I was thinking Friday, how many people are going to be out for athletic absences on Friday? No, men's soccer's here? Men's football's here? You guys are, it's homecoming, so you're here.
Women's soccer might be gone.
Women's soccer? That's fine. I'm fine with it.
Anyways.
Is Friday Halloween?
Yeah.
Monday? Yeah, it is.
I'd rather have Friday than Monday.
Yeah, it's either Friday or Monday, so I don't care.
Friday.
All right, put your hand up for Friday. All right, looks like Friday. So we'll have our next exam on Halloween Day, okay? So on chapters 4, 5, and 6. All right, and we'll review for that on Wednesday, next class, obviously. All right, so we're talking about networks, okay? We're talking about the cloud. And, you know, there's a lot in this chapter that I'm going to not go over, okay? So there's a lot of stuff in there. It's pretty detailed stuff for an MIS class, an intro to MIS class. So the concepts that I want to get out of this, however, is I want you to understand the basics of networking, okay? And why we network is important. Obviously, we share resources. And we talked about things like a local area network, a wide area network, and the internet, which is just an internet, a network of networks is all the internet is, okay? So let's just talk, I know we did this before, let's talk about some of the things that all come together to make networks possible, and we rely upon them in the world of business, So first thing, what does it start with in your computer? What's the hardware in your computer? Remember, hardware, software, data, procedure, people. What's the hardware in your computer that makes it possible for your machine to communicate with a network? What do we call that device in your machine? Goes by a little abbreviation as well, a three-letter acronym. It's called NICs, okay? So network interface cards. And you actually have two in there. You have a wireless NIC, which deals with the Wi-Fi, and you have an Ethernet network interface card. Okay, so that's a couple things we want to talk about. So when you plug in, okay, what do we call that cable? It's not really this, but it gets associated with that. What do we call the cable we plug in? We call it an Ethernet cable, right? And what that basically does is establish a connection from your machine's network interface card to what device that kind of links things together in a network. What do we call that device? Cisco is one of the big producers of these. It has a bunch of ports, what we call it a switch, okay? So you are, when you plug into that port, you are somewhere in a closet somewhere in Christian Hall or Giles Hall or wherever you're at. There's a switch, a device, and when you plug in, it's going to that port, okay, that's hard-coded, all right? And we're communicating in 802.3, and what is the speed we can get through? That's called Ethernet. Ethernet and 802.3 are the same thing. What are the speeds we can get with Ethernet? And how do we measure speeds? What are the speeds, the data transmission speeds we can get? It's important, right? Anyone ever been bothered by a slow network? Yeah. What are the kind of data transmission speeds we can get? What is it measured in first? Before we know what the hell, what it is. Go ahead. Hertz is a cycle. That's like the speed of processing power. But this is how much you can get through the pipe, basically, is what we're talking about. What are we sending through the pipe? Okay, we're sending through, we measure in bits, right? BPS, which is bits per second. Remember, lowercase b means bits, and an uppercase b means bytes. And we usually use, like, storage, we're talking about bytes. And then remember, 8 bits. So we're talking about like the ones and zeros we can get through that pipe. And when we talk about connection speeds like Ethernet, what kind of bits? Not kilobits, but we talk about megabits per second, okay? And Ethernet often says 10, 100, 1,000 megabits per second. And this is actually 1,000 megabits is actually a gigabit, okay? So that's the number of ones and zeros that can be sent through that pipe, basically that connection, in a second. And this is depending on what the device is. Like some old devices can only handle 10 megabits per second. You know what I mean? If it's an old printer or something like that, it'll connect at whatever speeds are appropriate, right? So that's the speeds there. Now, when we talk about accessing with our wireless network interface card, what do we kind of serve as a translator from what we communicate to the Ethernet? What's the translator? So what is the protocol we use for wireless communication? Let's talk about that first. What is the protocol? 802.11, also known as what? Better known as Wi-Fi, right? And there's different flavors of that. There's A, B, G, and I can't remember some other letters. And what does the book say that you can get with Wi-Fi? What's the fastest speed you can get with Wi-Fi? And this is like some of the later flavors of Wi-Fi. But what does it say? The book says about 600 megabits per second, but that's not the case in a lot of cases, okay? I don't know what we're connecting at when we use it, but 600 megabits per second is what the book says we can use.
This boost must be 10
10 what?
megabits
When you're talking about the Ethernet or the wireless?
to Wi-Fi.
If you go to, what the hell, why not? If we go to, there's a website that'll basically do that test jet for you. I think it's called speedtest.net, I think it is. Yeah, speedtest.net. If you want to do that, let's see, begin test. So what it basically does is, you see it says ping up here. Remember I talked about what a ping is? What's a ping? A ping is it's sending a packet of data. It looks like it's sending it to Pittsburgh, PA. And it's kind of measuring how fast it's going. So this is, so that's pretty good. We're getting, it looks like, about 100 megabits per second it looks like. So we're, it's going to come back with a report. So our download speed, this is a wired connection, is 97.8 megabits per second, which is pretty good. That's not bad at all. Okay?
That's a wired connection.
That's a wired connection, yeah. I don't have Wi-Fi. I don't know if this machine does, but you're going to get something differently. And it tests both the download speed and the upload speed. Okay, that's speedtest.net. So if you want to check that out. So actually, so that's not bad. That's pretty good, actually. That's a wired connection. Okay. Did you guys do it on Wi-Fi? Anyone do it on Wi-Fi?
It's at 5 right now.
Yeah.
It's at 5. Okay. So
It's halfway done.
it's halfway done. Okay. So, but you're saying like numbers around 5. Okay. So think about that. Okay, that is a big difference, right? I'm connecting at speeds about 20 times faster than you are. So that's while you're in your dorm room, it's best to do what? Plug in, right? If you're complaining about your Wi-Fi and you're right next to a port, that's kind of silly. Plug into the port. I know you have to carry a cable around, but you're going to get much faster connection speed. A couple things: that the protocol is faster, but also what you connect to when you connect to Wi-Fi is you connect to, what do we call that thing in the ceiling? We call it an access point. And all the access point really does is, this is Wi-Fi, this is wireless, right? It's all going through the access point actually has an Ethernet cable on it that goes back into the switch. So it kind of translates from 802.11 back to 802.3, which is all what all the data is based on. So some things maybe I missed on that. Let's see, I like this diagram a lot because it explains the basics of the network. So we have the switch, Ethernet. Okay, the other thing, so this is a local area network, and then we can have what's called a wide area network when we have networks at disparate locations. Like if you are banking, you might have a network that connects all your branches. And how do we connect disparate locations? Like when we go long distances. So you think about it, we have, for short distances, we have those Ethernet cables. And I know you guys have seen Kevin up in the rafters stringing Ethernet cable, right? So how about we go long distances? Like we want to, like, talk about the internet, we go to China, we go to California, whatever. What's the connection that's going long distance? Do you remember? Yes, fiber optic cable. And fiber optic cable goes at the speed of light, right? I'm not sure exactly how fast it can go, but it's the speed of light, right? Because its light pulses represent ones and zeros. It has a mirror cladding around it. And I can tell you, anyone ever still have dial-up at home? Anyone have dial-up at home? Dial-up internet access? No? No one lives in like the boonies? No? What does dial-up get you? What's the connection for dial-up speed? You know? Yeah, it's 56, that's max. 56 kilobits per second. So you think about that, compare my connection speed, which was, let's just say it's 56 megabits per second, and dial-up would be 56 kilobits per second. How much faster is 56 megabits per second than 56 kilobits per second? 1,000 times faster, right? I can still remember, and I know you guys don't like me telling these old man stories, but my first job, I was on call, okay? And supported bank software. And I used to have to take home this terminal and this modem, okay? A modem stands for modulate, demodulate. It converts analog signals to ones and zeros. And the modem was a 600 baud modem. Okay, and what that means is it could handle, not kilobits, it could handle 600 bits per second. That was it, 600 bits per second. And now we're talking, what, like 60 million bits per second. So it went from 600 to 60 million, in the last 25 years or so. Okay, so that's the kind of growth we've seen. It's crazy kind of growth. So we talked about fiber optics. Okay, very good. And Google, like for example, has a project where they put in Kansas City, Missouri, and there's another Kansas City. I can't remember where that Kansas City is, but they put fiber optic. Like everyone has fiber optic into their houses, into their, because it's called a Google project, and they want to extend it, but it's crazy kind of speed. That's like you can stream anything, basically. Okay. So a couple things that we touched on, but we didn't talk about so much, is we talked about the domain name systems. I guess we did talk about that. We talked about IP addresses, which uniquely identify everyone on the network. We talked about URL, which is the thing you type in your browser, Uniform Resource Locator. The domain name gets translated to an IP address. That gets translated to a machine. And that gets translated, I found it now. Where is Ben from? Here's what I wanted to show you last class and I couldn't find it. Ben.
So it's domain name to IP address to IPv4?
It is. Let me. I can't think and type at the same time. Okay, so what happens is when you type in a domain name in your browser, right? That domain name is the user-friendly thing, like francis.edu. That's what you know as a human, right? But really what the network needs to know is like the actual address, right? It needs to know the actual address. So that gets translated to an IP address, like 109.87.43.22. And what happens is, I think I told you there's a bunch of routers on this network, and all routers are like traffic cops of the internet. And it doesn't know exactly where that domain name lives, or that IP address is, but it does know, generally speaking, if it starts with this number, that means I ship it this way. If it does with this number, I ship it this way. And I use this zip code as an example. For example, if I type in a 1, okay, for the first digit of a zip code, you see all of those areas have a 1 in a 5-digit zip code, right? And then I go to a 5, and then it goes down to, looks like southwestern PA, central PA. And then I go to 9, now well, that's probably Cambria County. And then I go to 4, and that might be, I don't know, that's Portage and Loretto and some other fantastic places. And I type in 15940, and then we get to Loretto. And the domain names kind of work that way as well, okay? Where the traffic cop says, hey, I don't know exactly where this is, but I know it's this way. And it sends it to the next router, and this router says, I don't know exactly where this is, but I'll send it this way. And then finally, you get to a router that goes, hey, I know exactly where that server lives. It's in Utah, and it's this server in Utah. It goes to Utah. It looks for the, remember the slash meant a folder. It looks in that folder, and it says this person's looking for this file. Pull this file, send it back to the browser, the whole way back to that path, right? Let's give me someone. We have any students from far out of state?
New York.
New York? I don't think we have. You don't have a zip code in Mexico, do you, Pablo?
Houston.
Huh? Houston. Give me Houston. Go ahead.
7-7.
What is it?
7-7.
7. Looks like we're in Texas. Oh, southwestern Texas.
492.
492. Okay. That Katy, Texas? Is that right?
Yeah.
Okay. And truthfully, it goes beyond this. I mean, I'm not going to get in the zip code, but that's your 4-digit zip. Does anyone know their 9-digit zip? Yeah. Katie, you know yours? Yeah. And that gets that right down to your house, right? Like mine's 159462060. That's really my house. It's unique to my house, right? And it could be if I had multiple like apartment buildings, it would just be the apartment building, right? But it gets down to a physical building. And there's actually an 11-digit zip, and the 11-digit zip has like the carrier code on it. Like who the hell is going to carry the mail, right? Like 02 is this carrier, 03 is this carrier. When banks and people that send out a lot of mail to save money, like what do we pay for a stamp? I don't know. What's a stamp? 49 cents. Well, that's expensive, right? That's if I send out 1 million statements, that's $500,000. So what banks do is they pre-sort it and they put on like they actually put on the 11-digit zip code so that it's easier for the United States Postal Service to process it, right? They don't have to do the processing, and then they get a reduced rate, like maybe I don't know 30 cents or something like that. Okay, but that's exactly how the network's working. It's trying to say, you know, so we take a complicated thing, but we do it so fast that it's unbelievable, okay? So that's what a uniform resource locator helps us with. I don't think I talked about this, but the people that help us, I did say a domain name's relatively cheap to reserve. It's about, you know, depending where you go, $10. You get deals for like $2. But the people that reserve names for you are called registrars, okay? Registrars. GoDaddy is an example of one. Oneandone.com is an example of one. If you just type in registrars, there's a lot out there. Dotster, Yahoo, a lot will do that. All they are is they are sites that have been licensed to reserve domain names for customers, okay, for a fee. Okay, GoDaddy is one. Now, let's talk a little bit further. So we have a domain name, and this is an e-commerce class, but we have a domain name. We want to start our own web business, right? We have a domain name. $10, that costs it. What else do I need when I want to start an e-commerce business or even start a website? So I have a domain name, so I know I can give something that customers know me by. johnmico.com, right? And it translates to some IP address. But what else do I need? Think about the URL. What else do I need? Okay, well, all right, so I have johnmico.com, okay, I can reserve the domain names, but that's fine. All that is like a brand. That's a name, right? What do I need when someone types in johnmico.com? It needs to do what? I need to tell the internet to go somewhere, right? And that somewhere is a server somewhere, yes? You guys know what I'm talking about? So what we call that server, that web server, is we call that a host. Because that's where I'm hosting my web pages that I'm allowing people to retrieve. So your book talks about a 3-tier architecture. And that's how a lot of websites are designed. First of all, you have the user tier. That's what you're using. That is your browser, your cell phone, your tablet. That's the user tier. That's the browser. That's the interface that you're looking at. Say, you type in the URL saying, I'm using this protocol, go to this domain name, which translates to an IP, go to this folder, pull back this file. That's the user tier. Now, the network says, all right, we're connected to this domain name. It needs to get to a server somewhere. And you don't know where that is usually, right? When I did that, I think I typed this trace route in, and it kind of timed out on me. But if I do CMD, and I do trace route, I know this is in a server in Pittsburgh, So I go to portagepa.com. What it's doing is it's going through the various routers that I talked about to try to get to this web server that has my files on. It has portagepa.files on. So you see it went through ACUP, which is an organization that we partner with to get reduced internet rates. There are other universities, I can't remember what it stands for, but we go through their gateway, and then it's getting to Pittsburgh. And it might time out on me because it's prioritizing this traffic very low, but it's eventually going to arrive at 209.197.85.142. And that tier, those servers, okay, those servers are called, so it did arrive at 209.197.85.142. If I do a trace route for, God bless you, let's do Dell.com. I'm sure that's not hosted in Pittsburgh. Might take some time. Okay, we're leaving St. Francis. We're going to, looks like it's probably Chicago. I don't know where TW Telecom is. Sometimes you can tell the city and sometimes you can't. But anyways, it's going through multiple hops to get to Dell server, okay? And we talk about servers. I'll let that run up here. That timed out. We talk about servers. Servers can have a lot of things on them. They have what we call web server that processes these web requests. We can have other applications that are running, and computer service application. So that's the second tier. So we have both the user side and the server side. The third side kind of covers exactly what we just talked about, and that's the last chapter, which is the database tier. So let's think about, how does a place like Amazon, obviously they have a domain name, Amazon.com, which in itself is worth hundreds of millions of dollars for that domain name, right? Because they built that brand. So if I have nothing, if they get rid of all their servers and all their inventory, they could still sell Amazon.com, that brand name, for, I'd say, $100 million. Guaranteed. All right, probably more. But anyways, you type it in, it goes to their server. Why do we need databases? Why does Amazon need databases? Why does Amazon need databases to facilitate that request? What kind of things you think Amazon uses to store in databases? Yes.
Aside from like your contact information, like
Okay,
your
so
things you,
customer information, but how about when they deliver a product page to you?
so like the things you're frequently looking at.
Okay, so they're definitely storing information about you, the user. But let's go to Amazon.com and let's put in, I don't know what the hell that is, but let's check it out. The Fire TV stick. Let's take a look at the Fire TV stick. All right. How many people have shopped on Amazon.com ever? Okay. Does every page look pretty much the same? How's every page look? I don't even have to look up here, but what's up in the far left corner? Always.
Amazon.
Not that far up, but what's the product page? There's always a picture of the damn thing, right? Whatever it is, there's a picture of it, right? If I go to, I don't know, let's say, I think they sell, there's a tank for sale on Amazon last I saw. Let's see, a tank. Not a tank top. All right, let's go to the tank top, okay? I'd like a red one. All right, there we go. So, they have a picture of the thing here, right? What do they also have? Well, they have a little description, like a title of it. They also have the customer reviews, they have sizing, and if we go down, they also have, product description, which is always in the same location. They have customer reviews, which are in the same location. If we go down further, they say people who bought this may have also bought this. Customers also viewed this kind of stuff. There's my recently viewed items. Anyways, or someone's recently viewed items. I don't think it's logged into me. But anyways, so how do you think it might use the database to serve that web page? Think about it, since all those things are in the same place, every damn product I look at, if I go to a baseball bat right now, it's going to look the same way. So how might it use a server to serve that page? Let's go to luggage. Looks the same, doesn't it? Picture here, description here. So what do you think? How was the database used to deliver that page? Nothing? Okay, all Amazon has is a item template, right? And they say load the item template, and what product am I looking up? Well, every product on Amazon has a unique ID. I don't see it here, but I'm sure there is a unique ID. So think about, what does it use that unique ID for? What do you think it's using that unique ID for, that we called a primary key? It looks it up and it says, all right, what do you think Amazon stores about every unique item in its database? What's one thing it stores so it can display it to me on this page?
Picture.
Displays a picture, right? What else does it store?
Different colors.
Right, the options, right? It stores the title. It stores the reviews associated with it. The reviews associated are going to be in a different table, don't you think? And what do you think the foreign key in that review table is going to be? It's going to be point back to the item, right? This is John Miko did a review of this item, right? And think about it. There's a user table that has John Miko in it, right? And John Miko wrote this review of this item. So think about that, how the things come together, the database here. All this stuff comes together to deliver the stuff that we use in the world of business, okay? So those are the three tiers, and that's how they're in action. So any kind of robust, web application or application in the cloud has those three tiers. It has the user tier, the web browser, the thing we access it through. It has the server tier, what sometimes we call hosting, and then it has the database tiers. For example, has anyone ever developed a website?
Once.
What did you use? What did you develop it in? Did you use like HTML or did you?
HTML, yeah.
Did anyone ever use WordPress? You ever hear of WordPress? What is WordPress?
The blog.
It's like a blogging site, but how does it work? Does anyone know how it works? Yes?
They give you a template you can choose from, and you can click it, and you can customize it a little bit depending if you buy it or
Okay.
you pay for it or not.
So exactly, it gives you like a template. Like I don't have to develop this thing from scratch, right? You can go out and Google WordPress templates, and there's hundreds and thousands of them. There's free ones, and there's ones that cost $20, and there's ones that cost $5,000. Yes? And what it does is says, hey, you know what? This is what the design is, and if you want to add your own content, go ahead and add your own content. All your content gets put like into a database. It's called a content management system. So it says, let's take the design aspect and put it over here, these templates, and then you can add your content over to this database, through an interface, which is kind of nice, and I'll display it that way. So we don't have to be a web developer to build a pretty nice website, okay? We can use WordPress or other types of content management systems. But that's what it uses, a web browser, it uses a server somewhere, and it uses a database application, okay? All right, the last thing I want to cover in this chapter, so understand the three tiers, and I think maybe we've done that to death, is I want you to understand these buzzwords, I guess, or these terminologies. Because we're talking about the cloud, and we talked about a lot of the advantages of the cloud. We said, hey, we don't have to have it in-house, we have it professionally managed, we can share resources, we can access it 24/7 everywhere. Well, a lot of times in the business world, you'll hear these terms. The first one is software, and then they use lowercase aa, software as a service, okay? Can you give me an example of software as a service? Software as a service says, we go to the cloud to use some kind of software application, and that place might charge me for that service. They might charge me, I don't know, $5 a user or $10 a user. Go ahead.
Dropbox.
Okay, Dropbox is a good example. It is software as a service, right? As a service. So it'll give you free, maybe like 5 gigabytes free, but it says, hey, if you want to use more, okay, then you're going to have to charge. I'm going to have to charge you $10 a month or $5 a month. That is software as a service. Go ahead, Matt.
Maybe share file.
Okay. I've never used ShareFile, but is it similar to Dropbox?
It's like just the different like files, like pictures or something.
Okay. Very good. Yes, that would be an example. Even remember we use Google Apps in here. We use John Miko. You guys remember that? Well, it used to be free. You used to use Google Apps. They'd give you 25 users free, and I'm grandfathered under that. But now they charge, I think it's like $50 a user per year. Okay, so because they have a lot of things with it. They have Gmail, they have a calendar app, they have all kind of, they have the Google Office, all those kind of things. So they charge so that's software as a service. So software as a service is, and it gives some examples here, Salesforce.com, we'll talk about that a little bit later. That's a customer management system, okay, a customer relationship management system called a CRM system. So instead of us developing our own customer relationship management system, which is, think about it, what kind of software is it, vertical or horizontal? Since everyone has customers, do you think customer relationship management software is vertical or horizontal? It's horizontal software. So if it's horizontal software, we're probably going to go out and buy it from a vendor, yes? And in fact, instead of installing it at our own place, we'll just say, hey, Salesforce.com, can we pay you like 10 cents per customer that we put in here? And they're like, sure. You can use our web interface, all those good things, up and running like that, right? It's a beautiful, beautiful thing. iCloud, Office 365. iCloud, I guess, is Apple service. I haven't used it. What's Office 365? Anyone ever use Office 365? You know what it is? What is Office 365? You guys know what Office is, right? You guys are using Office 2013. What is Office 365? Office 365 is Microsoft's version of Office in the cloud. And what they say is instead of you installing, it's kind of like, it's like Google Docs almost. Instead of you installing Microsoft Office on your computer, you go out any place, anywhere, and can access a spreadsheet, Excel, or PowerPoint, or whatever it might be. Okay, so they charge for that. The other two are less common. Like, you better know software as a service. That's for sure. The other two, probably as just a business person, you may not have to know these, but the other two are platform as a service. And platform as a service is, I want to build my own application. Okay, I want to build my own custom application, but I don't want to buy my own servers, build my own databases. I want someone that already has done that, and I'll use their platform. Okay, platform as a service. Microsoft Azure, Oracle On Demand are examples of platform as a service. So they'll provide a platform for my developers to build this thing upon. Okay, and the last one, and these two are kind of related actually. The last one is infrastructure as a service. So infrastructure as a service says any kind of hardware we're going to put in except for hardware like the user tier, like the things you have to have your computers, we're going to put in the cloud. Amazon S3 is all your storage for your company would be in the cloud managed by Amazon. EC2 is processing power. It's like server processing power. And I can configure my machines however I like. So these last two, platform as a service and infrastructure as a service, are kind of closely related. Okay? I'm not going to cover that. And these are, we talked about server farms. These are Amazon's server locations across the world. So you see in North America, the closest one, they have one in Virginia, I thought. Yeah, Roanoke, Virginia would be the closest one to us. But they kind of, they're kind of spread out over the United States. So they have a huge server farm in Virginia that can, host a lot of different sites as software as a service or inventory as a service. I'm not worried about any of these things. And that's good. All right? So a lot of that stuff is not germane or important. What I would like you guys to do, we have about 10 minutes together, so I'm going to pass this out. 1, 2, 3, 4, 6. Pass these back, please. Pass those back, please. Pass those back, please. Got extra? Okay. I want to talk about something called packets. Oh no, I lost it. Okay. And what packets are is when we send a message over the internet or any kind of data, it breaks it up into envelopes and sends them through the network. Remember we talked about, remember we were in trace route and the things went boom, boom, boom from here to here to here to here until it ended up in its final destination? So let's say that I want to send a message to Jeremy back there, okay? So I'm sitting over here in Portage, Pennsylvania, and you're sitting in Long Beach, California, okay? And I want to send you a message, whatever it might be. So what I do, and this happens behind the scenes, is this message gets chopped up into little envelopes because we don't want to have a physical connection between me and Jerry. That's called a circuit switch network. We're doing something called a packet switch network. So we break up that message in little packets, and I say, I don't know where Jeremy lives, but I'm going to send it to the guy that I send everything to. It's Jerry. He's my gateway, right? Jerry's my gateway. And then Jerry doesn't know exactly where Jeremy lives, but he knows how to get it closer to Jeremy than I do, right? And then he sends it to whoever. But I'm going to start injecting these packets in. They got to go back to Jeremy, okay? So deal with it. Don't open it. What are you doing? Hey, packet, router, get up. Okay? Now, where's that going, Christina?
I have no idea.
Very alert today.
Yeah.
All right, keep going.
Fine.
All right, I got a whole message. All right, a couple things I want you to know. Did every packet take the exact same path? It did, okay, and that's true of any kind of connection on the internet because maybe some routers are down, right? Maybe she was offline, yes? That happens. And we have to have a turnaround, right? We have to go, we'll go around her, right? So that happens. A couple other things I want you to notice. How many people, or how many different distinct people touched that message? And actually Frank started opening up and went, hey, that's a security violation, right? And Christina started opening up, that's a security violation. So think about that, okay? When you're sending something across the internet, think about that, okay? How many places actually have control of that information that you think is secure? So it has to be encrypted. Jeremy, did you get the message? Did you receive it, Jeremy?
Am I supposed to open all of it?
Yeah. So you're the end result. Boy, I'm making a mouthful of 4 envelopes. So please decipher the message. And this is what happens on the other side. It gets encrypted, it goes through, it's broken to packets, and then it gets decrypted and re-put together. That's not a good word, but not re-put together. What's a good word for that? Reconstructed, thank you. Reconstructed on the end. And what's the message say, Jeremy? Okay.
Really said 2 or 3. So
All right, so, okay, I did that on purpose. 2 of them say, they're all labeled. It says 1 of 3, 2 of 3, and 3 of 3. But 2 of them say 2 of 3. Because what happens on the network is you send back, and you didn't do that, but you would send back a message and say, hey, I got 1 of 3, I got 2 of 3, I got 3 of 3. But if you don't say, I got back 2 of 3, what I would do is say, hey, he didn't get it yet, so maybe he got lost. Maybe Christina did fall asleep. I'd send it again, right? And sometimes one just took longer to get there. So then you get duplicates. And what do you know to do on your end if you get duplicates? What are you going to do, Jeremy? You're going to delete it or ignore it, right? Okay, delete it. Very good. So now you got, so what's the message that I sent?
I love MIS.
Yeah, but what you're supposed to delete that one packet. So what's it going to be?
I love MIS.
There you go. I love MIS. So think about that. When you send something on the internet, think about how many hops it goes through and how many people touched it. Now, even worse, at least those are physical connections. How about right now? I'm sure not all of you are paying attention to me, and I'm sure some of you are doing things on your machine that you shouldn't be doing, right? Where's that information going? Where is it? I don't know, you're I don't know, IMing your girlfriend, or you're sending a Vine. I don't know what the hell you're doing. You're yakking about Dr. Miko. I don't know what you're doing. But where's that information going from your wireless network interface card right now? Not the cloud. Where's it go first, Matt? It's going from your wireless network interface card to where? Where's the first stop? Boom. Okay? And how's it transversing from Maya's laptop to that access point? Through what? in the air, guess what? I could intercept that, right? I could. There are things called packet sniffers, okay? Kind of a odd term, right? Packet sniffer. But what packet sniffers do is they can detect and sniff packets being sent in the network and then do exactly what Jeremy did and try to reconstruct them, yes? So I could turn on a packet sniffer, and I could do that. I have the geek ability to do that. And capture all, that's kind of illegal, and I'd probably get fired for it, but I could capture all the information you guys are sending this packet sniffer, reconstruct it, and say, oh, there's MIS password. Oh, I guess Jeremy's having a hard time with his girlfriend right now. All those things I could say, right? I could get those things. So that case you're about to read is talking about these things called packet sniffers. What I would like you to do, there are 8 questions. Let's see, we have 4 rows. So I would like you guys to do 1 and 2, 3 and 4, 5 and 6, and 7 and 8. Okay? And then we'll start off Wednesday's class by talking about them. And then we'll review for our exam that is via vote, Halloween Day.
When will you send out the study guide? Like today.
What's that?
You should try like today.
I'll try. But I can't say I'll be able to do it.
I'll expect it away.
Yeah, you keep expecting.
I'll expect it.
I expect another victory this weekend, all right?
This for Wednesday then?
Wednesday, yes, yes. It shouldn't take you long. Just read the case. If you do nothing else, read the case.